All right, now we get to talk about absolute values and what the absolute value actually represents. The absolute value of a number is the magnitude of the size. For example, the absolute value of 3 is 3, the absolute value of -5 is 3. More commonly throughout the years, you've probably heard this described as the absolute value represents the distance from 0. That is oftentimes how I will refer to it, as opposed to the magnitude. Just from an intellectual standpoint makes a little more sense. So if I have the absolute value of a real number, that means I know that if the absolute value, if I'm taking the absolute value of a positive number, I'm going to be getting out just a number. If I would take the absolute value of 0, it's special. There's only one thing, it's 0. And if I have the absolute value of a negative number, I'm still going to be getting the absolute value of A. Okay. Really not too much to talk about here. Basic absolute value expressions or properties as well. The absolute value of the distance away from 0 is always greater than or equal to 0. I can take an absolute value, break it up into two different parts, meaning if I have the product of two numbers inside of an absolute value, I can break that into the absolute value of those two numbers being multiplied together. I know that the absolute value of the negative version of a number is the same thing as the absolute value of the positive number of that version. That's actually where we get to, when we're solving absolute value equations, two solutions. And just like how we could take our product and break it apart, we can do the same thing with our quotient, because again, multiplication and division are essentially the same thing. So based off the definition of the absolute value here, if I'm looking for the absolute value of -4, the distance -4 is away from 0, the magnitude of that number -4, the absolute value of -4 is 4. That's pretty straightforward. The next one, the absolute value of pi minus 6. Well, this one's a little bit harder to kind of wrap your head around. If I think about this, pi is approximately 3.14, so I have to be a little careful here with how this expression is written. So I'm thinking about this, I have the absolute value of 3.14 minus 6. This is going to be, well, let's see here, 3.14 minus 6 is 2.86. So this is going to be the absolute value of -2.86, which means my absolute value is actually 2.86. So I can't just say the absolute value of pi over 6 is pi over 6, because 3.14 minus 6 is going to give us a negative number. I actually need to take these two and flip around, because I want to get out 2.86 roughly, and 2.86 is actually 6 minus pi. Okay. Your turn. What I'm going to ask you guys to do right now is quickly pause the video and just evaluate these two absolute value expressions. Should take no more than a couple seconds. All right, here we go. The absolute value of 7 is 7. 7 is 7 places away from 0. And the absolute value of 5 minus pi is 5 minus pi. I don't have to worry about the same thing I did in the previous example, because 5 minus pi is not a negative number. Good. And because we're talking about absolute value and the distance away from 0, it would make sense to logically start talking about the distance. So let's talk about the distance formula. The distance between -1 and 4 on the number line is 5. This distance away may be found by just subtracting the smaller number from the larger number. If we use an absolute value, the order of subtraction does not matter. That's what's beneficial about the absolute value. If we had a number line, we can just count. It doesn't matter which order I subtract them in. We're still going to get the same distance. So the distance formula, if we're just talking about a number line, is just let A and B be real numbers. The distance between A and B is just the absolute value of the difference of A and B. And really, I could say that A minus B and B minus A are interchangeable there, where I could say that the absolute value of A minus B is actually equal to the absolute value of B minus A. To find the distance between 2 points that lie on the same horizontal and vertical line, the Cartesian plane, we use the distance formula for points on a number line. For example, the distance between x1 and x2 on the x-axis is the absolute value of x1 minus x2, which is equal to the absolute value of x2 minus x1, which is why sometimes when you see the distance formula, you'll see it as x2 minus x1, x1 minus x2, it's the same thing. And the distance between points y1 and y2 on the y-axis is the same exact idea. Y sub 1 minus y sub 2 is equal to, the absolute value of y sub 1 minus y sub 2 is equal to the absolute value of y sub 2 minus y sub 1. To find the distance between 2 points, P, which is x1, y1, and Q, which is x2, y2, that do not lie in the same horizontal vertical line, we form the right triangle determined by P, Q, and R, where R is just going to be forming that right triangle. Again, this is probably how this was explained to you when you were taking geometry. So if I'm trying to find the distance between a point P and a point Q, what I end up doing is I form a right triangle. I know that a right triangle we can relate using the Pythagorean theorem. A squared plus b squared is equal to c squared. And that is essentially all we're doing for the distance formula. So we form that right triangle, we use the Pythagorean theorem, we take the Pythagorean theorem, we manipulate it to get solved for our hypotenuse, and what we end up doing is getting the distance formula, right here. The distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. And again, the note below that, it doesn't matter what order you subtract them in as long as you're staying consistent. So there's your distance formula. So now that we have recapped the distance formula, let's actually take a little bit of time to apply that distance formula and find the distance between a couple different points. So just find the distance d between the points 1, 5, and 6, 2. Now if I want to, I can just plug and chug and use the distance formula. I personally like visualizing what I'm doing, so I'm just going to make a really rough sketch. 1, 1, 2, 3, 4, 5, there's the point 1, 5. 1, 2, 3, 4, 5, 6, up to, there's the point 6, 2, and I'm trying to find that distance. So it helps me visualizing that instead of actually just plugging and chugging into that distance formula, it can help me visualize it. So I can see the distance from 1 to 6 is 5, and the distance from 2 to 5 is 3, so I'm able to tell what the pieces of that distance formula are. So for example, I know that that leg is 5 because the distance between 1 and 6 is 5, and I know that the length of the other leg is 3 because the distance between 5 and 2 in that y direction is 3. So I know that really this distance is equal to the square root of, and really that 5 again came from 6 minus 1 squared, and that 3 came from 2 minus 5 squared. Again, it doesn't really matter what order you do that in, but I used 6, 2 as my first point, and then 1, 5 as my second point. And 6 minus 1 is 5. 2 minus 5 is negative 3. And just to kind of highlight this, there is where we're seeing our 5 and our 3 from our leg lengths. 5 squared is 25. Negative 3 times negative 3 is 9. And 25 plus 9 is 34. So I get the square root of 34. Now, that is the exact value. If I think about the square root of 34, I can't simplify this at all. It breaks into 2 and 17. 17 is prime, 2 is prime. So that's exact as it gets. However, if I wanted to write a decimal approximation, I could. I would just have to take my calculator and type in the square root of 34. Remember, if I do need to get a decimal approximation, the standard is to round the decimal to 3 decimal places. So 5.831. Now remember, always assume that we want an exact value unless otherwise specifically indicated. All right, what I'm going to ask you guys to do right now is to pause the video, and you have another basic question here where you have to find the distance between 2 points. Why don't you try that right now? All right, here we go. Drew a little sketch, didn't need to do that, but it helps me visualize it, figure out my distance by taking the differences in the x's, the differences in the y's, squaring that, and getting my solution. I ended up getting the distance was the square root of 72, which can get simplified into 6 square root of 2. If you don't remember how to do that, again, that square root of 72 can get broken into 36 and 2, but the square root of 36 is 6, which is why I get 6 square root of 2. And if I wanted a decimal approximation, it would be approximately 8.485. Okay, cool. And that'll actually be a good place for us to stop, and we'll do the midpoint formula in the next one.